Okay, so this is actually our last video, so sorry about that. What we're going to learn about here is something called a binomial theorem. And before we do that, let's just talk about what we know about binomials. Remember, a binomial is a polynomial with two terms. So we look over here and we have an x and a y. Those are the two terms. Well, if we do x plus y to the 0 power, right, you know that means we have 0 of these, and anything to the 0 power is 1. If we do x plus y to the first power, well, that would just turn out to be x plus y. And now we're going to do x plus y to the second power. So we're going up from 0, 1, 2, just like our sequences and series we've been doing. So x plus 1 squared is x plus y times x plus y, which if you FOIL is x squared, right? X times x is x squared, outside, inside, and then last. And we can combine like terms in the middle and get x squared plus 2xy plus y squared. Okay, so that's what x plus y squared equals. Now, we could keep going with x plus y cubed and x plus y to the fourth and keep going forever, but that takes a lot of work. And eventually what mathematicians figured out is that there's a pattern to this. And specifically, this guy down here, this guy named Pascal, kind of figured this out. So if we continue this pattern and generate a series for x plus y to the n, right? So that's what this is here. This is we're going to use a and b now. So a plus b to the 0, to the 1, to the 2, to the 3, like that. If we do that, this pattern emerges where a plus b to the 0 is just 1 times a to the 0, b to the 0, which is just 1. The next one, a plus b to the first power, is 1 times a to the first, b to the 0. Well, b to the 0 is just 1, plus 1 a to the 0. Well, again, a to the 0 is just 1, b to the 1. So that equals a plus b, which is very similar to our pattern up here, right? We went 1, then we went x plus y, and now we're going to go x squared plus 2xy plus y squared. So we take a look over here, we do a plus b squared. Well, it's 1a squared, b to the 0, so that's 1. So that's 1a squared. Plus 2a to the 1, b to the 1, so that's 2ab. And then plus 1a to the 0, which is 1, b squared. So see, this right here is the same as this right here. And this pattern persists. We can see this pattern if we keep going. So a plus b cubed. 1a cubed b to the 0 is just a cubed. Plus 3a squared b to the 1 plus 3a to the 1 b squared. I probably should have not put this 1 here, so get rid of that one. All right, so we do our 3a to the 1 b squared plus 1a to the 0, that's just 1, b cubed. So if you had to do a plus b cubed and you didn't have time to FOIL it all out and you remembered this pattern, you could just write down the answer just like that. And that's what we're going to learn how to do. So instead of remembering all these a squared, b zeros, and all this stuff, we're just going to learn how to remember these numbers. And it's real easy. Kind of a neat little math thing. So we're going to make a triangle, and we're going to start with the number 1. And underneath the 1, we're going to put a 1 and a 1. Now we're going to start another row for our triangle that's also going to start with 1. But instead of just being a 1 and a 1, we're going to do this middle section here. 1 plus 1 is 2, and then a 1. And now we're going to start another row that starts with 1. 1 plus 2 is 3. 2 plus 1 is 3, and 1, and that's how this pattern continues. So you look at the row above it, you start with the 1, so this is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and it ends with a 1. All right, 1, 5, 10, 10, 5, 1. And that's the pattern we see here. So this pattern is this pattern. Not too bad, right? So the binomial theorem is the expansion of x plus y to the n. And x plus y to the n is always equal to x to the n, and then this pattern here. I don't expect us to work with this any, just so you see it. So it says x to the n plus n times x to the n minus 1 y. So if you knew what n was, you could just fill this in, right? And when we're doing this table, it might seem a little confusing that I write this right now, but I'm going to put a 0 up here just to help you and let you know that these numbers right here tell you what n is if you're not sure. So this is n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, and this is n equals 5. And if you look back up at our expanded deal up here, you can see that when n equals 0, we just have 1. When n equals 1, right here, we have 1 plus 1, which equates to this 1 plus this 1. It lets us know that we're just going to have whatever our letters are, a plus b. And the pattern continues, and we'll practice with it, so it's not going to be that bad. Now, expand the binomial using Pascal's triangle. So we have x plus 8 to the 6th. Well, using Pascal's triangle means we need to fill this thing out until we get 6 rows. So here's our 0 row. 1, 2, 3, 4, 5, and then this is our 6th row. 1, 6, 15, 20, 15, 6, and 1. All right, so this is our 6th row. And the reason I know that, if I put a 0 up here and I count 0, 1, 2, 3, 4, 5, 6, I know that's the 6th row. So now this is the 6, 5, 4, 3, 2, 1, and 0th term of our expansion, which we'll see in just a minute. I'll just write that on there so you can see it. So looking back at the page before, we're doing the 6th row, which is one more than this, right? So we're going to have 1, a to the 6th, b to the 0. So we're going to have 1, and whatever this number is, so this is going to take a lot of writing, so we're going to have 1 x to the 6th times 8 to the 0. So we take this to the 6th and the other term to the 0. And we're going to add it. Now our next number, we just used 1, so now we use 6. So 6 x to the 5th times 8 to the 1st. Okay, because we just did 8 to the 0, now we're doing 8 to the 1st. So we're going up on this one, and we're going down on the x value. All right, plus, after 6 comes 15. So it's 15 x to the 4th, 8 squared. And notice our exponents always add up to 6. So 6 plus 0, 5 plus 1, 4 plus 2. So if you get confused, you can always double check there. So now we're on to 20 x to the 3rd times 8 to the 3rd. Both still add up to 6. All right, now we're to 15. So 15 x squared times 8 to the 4th. Now we're on to 6. So plus 6x to the 1st times 8 to the 5th. And last we're on to 1 plus 1 x to the 0 times 8 to the 6th. Now we're going to simplify all of this, right? So 1 times x to the 6th times 8 to the 0. Well, 8 to the 0 is really 1. So 1 times x to the 6th is just x to the 6th. And then 8 to the 0 is times 1. Okay. 6x to the 5th times 8 to the 1. That's 6x to the 5th times 8 to the 1. Plus 15x to the 4th times 64. Plus 20x cubed and 8 to the 3rd is 512. Plus 15x squared, 8 to the 4th is 4,096. Plus 6x, 8 to the 5th is 32,768. And then our last one we still have plus 1 times x to the 0. Well, 1 times x to the 0 is just 1. 8 to the 6th is 262,144. And you might be thinking at this point, well, I'm done writing. But it's not that bad. We're going to simplify it all from there. So x to the 6th times 1, x to the 6 plus 6 times 8 is 48x to the 5th. 15 times 64, 960. 512 times 20 is 10,240. Okay, 15x squared times 4,096 is 61,440. X squared. 6x times 32,768 is 196,608x. And we're still going to be plus 262,144. So that is, if you had to take x plus 8 to the 6th and write it out 6 times and FOIL it all to pieces, eventually this is what you should add up with. And I promise you, this way is a whole lot faster. All right, so we're going to save these two for class. We'll do this one as an example tomorrow, and then we'll do this one as an example. So let's go ahead and stop there and see you tomorrow.